Hello to all again. I'm Giacomo Chiesa from Polito, where I'm a professor. And I will speak in this session about the structure of the dynamic energy simulation platform that we have developed. The platform is called E-DYCE. It's supported by 2 projects at present, and the DYCE part stands for E-DYCE, in fact, and is a Python real-time energy dynamics and climate evaluator. It's a library and is composed by several modules, following a flexible, scalable, and modular approach. It's Python-based in terms of coding and allows pre-built different user scenarios in addition to the simple usages of code runs. It's conceived to be run and parallelized energy plus simulation in large servers and small computers, and may be recalled for some of the scenarios through REST API in order to be fully compatible with the middleware of the project that will be presented after me. In particular, the platform supports IDF editor. You know, IDF is an input file managing modeling in Energy Plus that can be built. The first IDF with simple approaches, or the approach that you retain, the better one, in different commercial or not commercial open source existing interface, from OpenStudio to Design Builder to RunAB and so on. We tested at least on 2 of them. After that, we also need a JSON input file that follow a sort of library, we can say, in which all action modification of the modeling is defined and structured. And we also will list a series of KPIs that we want to retrieve. KPIs are customizable, customized for the project, follow the EPC protocol, but we also have others. KPIs are not only computed inside the platform on model results, but also on monitoring results, if monitoring are passed as input. That means that we have the possibility to compare, I don't know, indoor environmental quality elaborated KPIs like adaptive thermal comfort or things like connected to free-running buildings in the same way on both monitored and simulated results. In addition, we run a model for Energy Plus, KPIs calculator models, and also a strong EPV compiler supporting real-time for cloud monitored data, EPV compilation, and for other issues and in other projects, also large climate databases. Inside the DYCE project, we use 3, and we have developed for the DYCE project 3 user scenarios pre-built, a sensitivity analysis scenario that support massive Energy Plus simulation runs. You can define a very large series of pre-built or customizable actions, like changing the retrofitting approach of the building from no hardened insulation layer outside, inside, or inside a cavity wall, defining the materials and so on, defining ranges of variations of the parameter that we want, or I don't know why, controlling the system, adding shading controllable system, and testing control logics. That support multiple requests also in terms of KPIs to identify optimal or behaviors of this type of things. This is also runnable through REST API. We have a calibration, which is a semi-automatic scenarios. Clearly, that's require human interface. We will see in a second that's based on a calibration signature approach developed by other researchers and so on, but that's integrated inside the scenario, supporting an automatic optimization, minimization, root mean square error, mean bias error, in comparing simulated and monitored data. Clearly, the monitored data need to be structured in terms of naming in order to be directly related to the model itself. So the tool is able to automatically fit model thermal zones and monitor it if correctly named. That's semi-manual because calibration requires in any case for this type of levels a sort of tuning or definition of ranges of variation. In addition to that, we have a performance gap scenario that supports the automatic test or under request test till arriving to semi-real time for comparison between the standard and the standard adapted, so this user-adapted approach in the EPC versus the monitored data for several KPIs defined inside the project. We see shortly some, you can say, in-depth analysis of these 3 scenarios. For sensitivity analysis, the tool clearly reports at the end not only the early results or the sub-early result of each simulation and some specific plots, not through the rest, but inside the tool it's possible also to retrieve a folder plot for each of the required simulation, including the KPIs, and also it generates automatically the permutation of the parameter according to the request and the given result for KPIs. That allow, for example, to detect heat maps with the impact of different retrofitting scenario on the given set of KPIs, or to control or optimize the control rules for shading, ventilation, and so on, helping at least designer. The calibration verification model is semi-manual because it supports a series of changes that is all the action that we want, but generally there are some pre-suggested one, at least by literature and predefined approaches and scenario, and generally these are applied one after the other. For that, there is need a small manual interfacing to not arrive at the end and not to have a wrong value or a wrong interpretation of the fact that the model is fitting, but the model is not a correct white box model representing the building itself. That's clearly exploit a PV compiler model and other possibility to integrate the monitored data. The approach follows calibration signature and use the ASHRAE standard for model calibration at the end. The last one is the performance gap scenario that has also a REST API. In this case, we need to pass to the tool additional data. So not only the model, okay, not only the JSON managing file or a MPV, but the tool may read the CSV data passed for monitored input. That's clearly with early integration. We generally, the tool is able to support early, we can say, after aggregation of results. The simulation is performed at least each 10 minutes or something like that, not to maintain the dynamics. At least that's a suggestion. And also the monitored data weather file if no a specific EPV was already built, no, in physics or in other part of our platforms. The scenario runs and performs a different type of results, so aggregated data frame, the time series, so for each of the simulation in each hour what arrives, KPIs identify also a peak and detection risk, not via the REST, but inside the tool is also possible to retrieve some plots, and also the CSV file with final simulation in which we have the aggregator for the time period required, weekly, monthly, whenever it is, of results for each of the KPIs for standard simulation, standard adapted simulation, monitored data, and the differences. In order to give the floor to Vangelis from the M10 companies supporting the physics integration, what we are already tested the platform in several demo cases inside our project domains. We are also now performing tests for the automatic test or check of the performance gap, retrieving these standardized KPI visions in order to also communicate to the user what arrives inside the building. So in some way the flow is, in this case, is that the E-DYCE simulation platform, the performance gap, is not run it manually or through the REST, but is directly recalled by the middleware of the project and is run remotely on our server without a direct control of it, for all the type of KPIs that we are identifying in the EPC protocol.